First things first. Can you take 22,740 and take away 15,707? 7,007. Add downwards. 14,138. Is that right with you guys? And then 7,007 take away 1,353. 5,654. You got 5 marks for adding and subtracting, okay? Now, these are details on different types of students in the university. We have undergraduates who are 23 and younger, postgraduates that are 23 and younger, undergraduates that are 24 and older, and postgraduates that are 24 and older. We have 14,138 undergraduates, 14,138 people under 23. And then we have 8,576 people 24 and older. Now we're going to do some questions about this now. One student is picked at random from the students in the university. Let O be the event that the student is 24 years old or older. Let U be the event where the student is undergraduate. Are these events independent? Yes or no? What's the proof for independent? There's a proof for it. PA intersection B is the same as what? You have to know the definition. PA multiplied by PB. Not on your table, so I've asked you to take it down. We did a full exercise on it. If you're asked to prove independence and probability, that's what you're doing. So what am I doing in this one? Probability of what? O intersection is the same as P bracket O multiplied by P bracket U. Okay. Okay. Now let's see what happens. What's the intersection? You're over 24 and you're an undergraduate. Would you agree? How many people are older and an undergraduate at the same time? 2922. Out of how many students? 22,714. So the probability of that happening is 2292 divided by 22,714. Agreed? Now, what's the probability of you being an older student? How many older students are there? 8,576 divided by how many? Out of 2,714. That's the probability that you're an older student. And what about probability of undergraduate? Both undergraduate, just an undergraduate. 15707, yeah? 15707 divided by 22714. Okay. Okay. This one here is 0.2186, and it does not equal when you multiply the two. What happens when you multiply the two down by 0.21, is it? So I've proved that they are not. Conclusion, they are not independent. That went for 10 marks, okay? And you're essentially just using, okay. Three people are picked at random from a class. The probability that all three were born on the same day of the week. Assume the probability of being born each day is the same. We've actually done this question in the book, not alone. We've actually done this exact question in the book, which is really, this is a really nice question for people. So what's the probability the first person's born? No. What's the probability they exist? 1. The day is irrelevant. Why is the day irrelevant? Huh? He exists. What's the probability the second day has it on the second person has it on the same day? 3 people are picked at random from the class. Find the probability that all 3 were born on the same day of the week. Oh, sorry, my bad. All three were born on the same day of the week. Yeah, I'm wrong. If all three were born on the same day of the week, what it is the first person's 1. Sorry, 1 sec. Yeah, I have it. The first person's born, let's say for argument's sake, on a Monday. What's the chance the second person matches his birthday? What's the chance the third person matches his birthday as well? That's your answer. First person can be born on any day. It's the second and third person that have to match the same day he was born. So that's 1 out of 49. B. Okay. There are B boys and G girls in the class, where B, G are natural numbers. So, for example, it could be 20 boys and 30 girls, where B is 20 and G is 30. Who knows? Okay. 3/5 of the students are girls. Okay. 4 boys and 4 girls join the class. 1 student is then picked at random for the whole class. Find the probability that this student is a girl is now. So 1 student is picked at random from the whole class. The probability that this is a girl is now 4/7. Find the value of B and the value of G. Now, I'd have to say, that's quite confusing, right? So let's break this down into what we can do. Okay. Would you all agree that the probability 3/5 are girls? Would you agree with that? So what this means is the number of girls G divided by the total is 3/5. Would that make sense to you? For example, 30 girls out of 50. That makes sense? Now, how'd you get the total again? What's the way you get the total? How'd you get the total? The total is B plus B plus G, isn't it? I'm going to cross multiply that now. 3B plus 3G. Do you see that? And then equals what? 5G. No, I've never done a question like this before. And then after this, bring the 5G over. 3G take 5G. What type of equation is this? It's a simultaneous, isn't it? So I'm going to have to create another simultaneous somehow. Okay, let's think about this. The probability of a girl is now 4/7. So 4/7 equals girls divided by total. Would you agree with that? Now, what is girls divided by total? What happened to the girls? How many people did we add in? Would you agree that it's G plus 4? It's your old number plus 4. And what about the total? It was B plus G. How many new people have you added in? Nope. Added 8 in. And now what happens? Look, we get rid of this middle part, fuse them together. Oh, sorry. Yeah, I'll just bring you over here. It's easier. Okay. Now, what do I need to do now? Cross multiply. 4 times B, 4 times G, 4G, 4 times A, 7 times G, 7G, 7 times 4, 28. 4B minus 3G equals minus 4, yeah? And then simultaneous equation. Find the value of B and the value of G so you can cancel either. So what I'm thinking is I'll multiply the top equation by minus 3 and the bottom equation by 2. And what I'll get is minus 9B plus 6G equals 0. And then I'll get 8B minus 6G equals minus 8. I'll add downwards. And I'm going to find out minus B is minus 8. This means my B value is 8. And if my B value is 8, that will make that 32 minus 3G is minus 4. This implies that 3G must be 36. Because 32 take away 36 is minus 4. So 3G will equal Minus 3g will equal minus 36. When I bring that across, g will equal 12. And you can check your answers if you want. 12 girls, 8 lads, yeah? So what was the ratio earlier? So that's 20 students total, isn't it? And what's 12 divided by 20? 3. 3/5. What they told us earlier. Then what happens when we add 4 more girls in? 16. What happens when we add 8 more students in? 28. And what's 16 out of 28? 4/7.